3.5, solving analytically, part B. Okay, same information here on the front page. What's a derivative? It's the slope, right? So let's go on to the next page. Now we're going to start asking for the derivative at a specific point. What is it at the point 2, 5? Right, if I plugged in a 2 here, 2 squared is 4, 4 plus 1 is 5. So this is the location on the graph, right? So if I was looking at this graph, x squared plus 1, like something like this, right? And what we're really saying is at this point, right, so at 0.25, what is the tangent slope? What is that slope? And we're going to find that out using this derivative thing. Now, I would recommend that you don't plug in the 2 at the very beginning and just do the x. So first find the derivative equation. So let's do that. That's f prime of x equals, and let's just do everything like we would have for just finding the derivative equation. So it would be x plus h squared plus 1 minus, let's do some brackets here, x squared plus 1 all over h. Oh, I'm forgetting something. This is the limit as h approaches 0. Okay, well, let's start simplifying this thing. This would be x squared plus 2xh plus h squared plus 1. And let's distribute that negative. It would be minus x squared and minus 1 all over h. Beautiful. We get an x squared minus an x squared. We get a positive 1 and a negative 1. And we can rewrite this in a simplified fashion. We could say that this is the limit as h approaches 0. Let's go ahead and factor out those h's. It'd be h times 2x plus h over h, and yes, those h's cancel out. So what is the limit as h approaches 0 of just 2x plus h? It's just simply 2x. Okay, so we know now that the derivative of x equals 2x. But that's not what they were asking, but that's okay. This is going to help us find it. Remember, they were asking what specifically is the slope at 2. This equation now would give us the slope for all points on this graph. So maybe we're asking for more than one spot. That's why I want to do the equation first. Saves me the trouble of doing it all over again. I have the equation. I'm good to go. So what is f prime of 2? Well, it's 2 times 2. It's 4. So the slope right there, right at that spot, is 4. The slope's 4. All there is to it. Let's do another one. Okay, a little bit more going on here. Again, I'd recommend that we just find the derivative for x, and then we'll plug in our x value later. So let's go ahead and go for it. F prime of x equals the limit as h approaches 0. Remember, I don't like using the delta x. I just use an h instead of these delta x's here. So this would be x plus h squared plus 2 times x plus h plus 1 minus, and I guess I didn't really need brackets, but parentheses, x squared plus 2x plus 1 all over h. Okay, let's expand this thing out. This would be x squared plus 2xh plus h squared plus 2x plus 2h plus 1. Distribute the negative, we get negative x squared, negative 2x, and negative 1 all over h. Well, x squared minus x squared cancels out. Positive 2x and negative 2x cancels out. Positive 1 and negative 1 cancels out. And I can factor an h out of everything. So out front I get h, 2x plus h plus 2. That should be all that's left over h. Now these h's cancel out, and so I'm really just asking what is the limit of h approaches 0 of 2x plus h plus 2? Well, if we plugged in a 0 for that h, it would just be 2x plus 2. Okay, so The derivative at any point x is just 2x plus 2. I want to know it at negative 3. So, what's the derivative at negative 3? Well, it's just 2 times negative 3 plus 2. And that's negative 6 plus 2, which is negative 4. So the answer to this is negative 4. The slope when x is negative 3 is negative 4. Okay. All there is to it. Now, the reason why I'm saying plug in the x is you could have, instead of plugging in an x here, and an x here, an x here, an x here, you could have actually just plugged in a negative 3. But the problem is you'd get the same answer, but we really, really want this equation because oftentimes we're going to be asked for more than one x value, and then we're going to have to evaluate the slope at multiple times. So if we get this equation first, we can evaluate for any point. So just work on getting the derivative function first, and then work on finding the slope. Okay. One last problem here. I'd encourage you to try this one on your own. Use the definition of derivative. Don't just use the derivative if you happen to have it memorized by now. But go ahead and give it a shot, and then we'll check back and see if you did it correct. Okay, so you've done this derivative before. Just do it for practice. As you go through it, you see you get this nice, neat equation that you're going to evaluate the limit as 2x of h approaches 0 of 2x plus h. Well, you just plug in a 0, you just get 2x. So there's your derivative function. Again, this is useful. You may want to just kind of have that one memorized for now, that x squared, the derivative of x squared is just 2x. We're going to see that a lot. And therefore, the derivative at negative 1 would just be 2 times negative 1, which is negative 2. That's all there is to it. So, pretty neat. That's it for this video. I'll see you guys in the next one.